will happen is that even though I'm this far away from the computer, you're going to hear everything clear. You'll hear questions when people come back and forth. If those guys sneeze a lot, you'll hear that.
Sorry,
Is it recording now? This is gonna.
Okay. So try this later when when you go to lunch. If you want to rewatch your stuff, I should be able to get this uploaded. You'll see it real quick. Thanks, sir. But we'll go from here. So, like you said, slopes just a rate of change of a line. We all understand the slopes as you define it. What was it? What was 1 over what? That's the slope equation of slope-intercept form. And most people say that when they first do that. That's usually the biggest mistake they do. Yes, rise over run, slopes. We all know slopes. Do we know why they use the letter M for slopes? All right, well, think about this. If you use, when you look at the letter S, what does the letter S look like? It looks like a 5. What does the letter L look like?
A 1.
A 1. What does the letter O look like?
A 0.
What does the letter P used for in math?
Perimeter.
Perimeter or probability. They use P for probability. And then E is the exponential function, the exponential button. Now, when they went through the whole alphabet looking through letters, they obviously could not use A, B, and C because the Pythagorean theorem was using those. They got to D. Well, that's used with distances. E didn't work. F they used with functions. They went on and on and on. So what happened was the first letter they came across that didn't have a use was the letter
M.
True story. I just made all that up and you all bought it. Anyway, you're right. It's rise over run. Have you guys ever seen the following symbol? It is.
Yes, of course.
What is it stand for?
The change of Y.
Change. Good. Change in Y over change in X. Good. They use the Greek letter delta for that. Now, when you're talking about slopes, you're always dealing with a set of ordered pairs. And one of the things you just want to make sure that you're working with when you have your ordered pairs, you have your first set of ordered pair and your second set of ordered pairs. Does it matter which ones are which? It really doesn't. As long as you are consistent with the way you label them as you're walking through, it always works. A lot of times the biggest mistake students make when they're dealing with slopes and finding slopes is if there's a negative value, or they'll accidentally flip-flop the X and the Y coordinate. It's very common. That's usually where you will make your mistake. So when you write it out, if you have to do long form, and I know this is all review for everybody, take your Y values, find the difference, take the X values, find the difference, and that's going to give you your slope. Okay? We all know that. That's a very common thing. It's one of the first things you guys all learn. So let's make a little running tally of some of the formulas for today. Here's the right change in Y over change in X. Now let's see if I can get you guys to think here. There are 4 types of slopes. There are 4 types of slopes. What are they?
Positive slope.
Positive slope, good. Negative slope.
And neutral.
Undefined slope. And what's the other one? Zero slope. So the 4 slopes. Now, if it's a positive slope, what direction is it going from left to right?
It's up.
Right. Up. Okay, from left to right it's going up. That's a positive slope. Then negative would be down the other way. What is the zero slope?
It's horizontal.
Horizontal. You know why you remember that? What's the second letter in the word horizontal? Oh, really? Or is that there? It's horizontal. You will find real quick my spelling is subpar. And then lastly, the undefined slope is a vertical line. If you have a horizontal slope, when you write out the fraction for your slope, Where's the 0? The numerator or the denominator?
The
Denumerator or the numerator?
numerator.
The numerator, correct. That means in the fraction it's 0 over some number. Because if it was 0 in the denominator, it would be undefined. So one thing to remember, real quick thing that you're going to see a lot of times here, if you're trying to write equations in lines or you're trying to write out stuff, if you notice you have the same exact x coordinates, it means you have a horizontal line. If you have the same y values, it means you're going to have vertical lines. Okay? Very simple to see. Like I said, you guys have all done this, you've all seen this. This is really not much new material here, I'm assuming. Right? Let's throw a little twist into it then. Let's throw the twist of giving you a set of points, give you a slope, one set of ordered pairs, and a missing coordinate. What I have here is I have a slope of 110. I have a set of ordered pairs at 4 and 2. So I have an x value of 4, a y value of 2. And then the other ordered pair, it has an x value of 14 and an unknown y value. And what I want to do is find that missing y value. So, like we've said in the past, the easiest way to get going on a lot of these things is to start by writing out the basic equation and then fill in the blanks. So we all know that the equation for slope was the change in y over the change in x. So I write it out, slope, the change in y over the change in x. Fill in the blanks. Let's see. I don't know, minus 2 over 14 minus 4. Yes, sir.
No, I was gonna answer it.
Oh, what do you got?
Y2 equals 3.
Good. In this case, there's a couple of really easy things you can do. We all see that 14 minus 4 equals what? 10. It equals 10. So in this instance, it's a very simple setup. That means 10 equals 10, and y minus 2 has to equal 1. So that means y has to equal 3. Do we agree? Now, what he did in his head was the following. When you have fraction equal fraction to solve for the missing variable, what do? Cross multiply. This is just a real simple example of how the setup works in your head. Is it always going to be that clean? No. Right. Does that make sense? You guys have probably did that before, I'm guessing. I think Severino does that with you guys. Did that with you guys last year in chapter 3. You're having heebie-jeebies from remembering that stuff?
I never did.
So that's about as complex as we go in here. So set up that one then real fast, please. I'll pause whiteboard. Bless you. With any luck, when you wrote it up, change in y or the change in x, you had that, right? When you cross multiply it out, you wound up with -1 times the quantity. Remember, if there's nothing there, you can just put it over 1. And it's just some simple simplifications here. Now, a lot of you guys might have done this a little bit differently. Let's get 6 plus x is 4. Did you get -2? A lot of times when I solve equations like this, I try to go to the very standard method. I try to go back to the way that most people were taught as far as substituting into the generic rule, and then just kind of feeding through that. And over time, I'll start to show more and more. I start to do more and more shortcuts. But obviously, if you've got a method that works for you, if you're doing things a little bit shortcutted out, I have no problem with that at all. All right, it's not that big a deal. So everybody does stuff just a little bit different. Okay. Questions about slopes? Alrighty, well, let's get into something a little bit more fun. Not to say that wasn't. I want to write equations in lines. So like I said, I'm going to combine 2, 2, and 2, 4 because you have to remember how to use slopes in order to use writing of equations. So now, What was slope-intercept form again?
Very good.
Now, like I said earlier, one of the things that a lot of students will do by mistake, when we first talk about slope, so many people have that ingrained in their brain about y equals mx plus b, y equals mx plus b, and they spit it out right away. And every year somebody does that, in every class. And I guarantee next hour when I do this again, someone else will say it too. You won't be the only one. And I bet you there's other people that we just didn't hear them say it. So when we look at writing equations of lines, there are multiple ways of doing it. The most standard way is using slope-intercept form. The reason why that's a very standard way is, like we said, it's y equals mx plus b. The reason why we like this form is because on our calculators, there's this awesome button. It says y equals. So when you're looking at lines, anything that's linear like that, that means you're going to be able to use your calculator to do lots of stuff. You'll be able to use your calculator on the table function to figure out values. You'll be able to plot, you'll be able to find intersection points very simply. When we get into working with systems of equations, we like to move things into slope-intercept form if we have to. That way you can use your calculator to find intercepts. It's a very useful method. Now, I'm assuming you guys all understand that M stands for, and B is the y-intercept. So we've worked that before. Now, I know it's crazy, isn't it? Do you remember point slope? What do you have if you have point slope form? Point to slope, very good. Point slope form. When you have a point and a slope. Kind of silly if you didn't have those two. Point slope form is also a very user-friendly method to create slope-intercept form. You use point slope form often when you had to write equations of lines that were parallel or perpendicular, or if you were things like that. So point slope form looked like this. Y minus y sub 1. And they use that y sub 1 because that's when they're talking about that ordered pair. Equals your slope times x minus x sub 1. So you're going to be given a slope and a set of ordered pairs. And once again, it's a direct substitution. When you write things out, it's a lot of making sure you read the instructions. Sometimes the instructions will say, leave it in point slope. Sometimes it'll give you the point and slope and ask you to write it into slope-intercept. That's kind of what I like a lot, because I think slope-intercept is very, like I say, very useful. That way you can use your graphing calculator. One of the other things, and we'll get to this maybe a little bit more tomorrow, in this class, every single graph that we do lines up with a shift. And as we get into some more of the funkier graphs, when we get into the absolute value function graphs, we're going to introduce you guys to what's called an H and a K, a horizontal shift and a vertical shift. This has that horizontal and vertical shift already built into it, but we don't normally introduce it yet. So just so you understand, when we always start things at the origin, your slope-intercept, your y equals mx, that stuff, then you added the b value, so it moved it up and down through the y-intercepts. Now you're being given a point and a slope to move things around again. So everything gets shifted around. So what happens now is that you get an example like this, where you have a point, 2, 3, and a slope of negative 1/2. And I'm going to ask you guys to use the point and the slope and rewrite it into slope-intercept form. So once again, all you have to be able to do is remember the equation for point slope. I wrote that down. We remember the equation for point slope, substitute in, and solve for y. Y minus 3 is negative 1/2, and x minus 2. What's the one mistake you're going to do? Not simplify, or better yet, not multiply correctly, the negatives. That's usually where most people make their mistake. When they move stuff, when they multiply out, they distribute out, they forget that there's a negative there. So you wind up with y minus 3 is negative 1/2 x plus 1. And then lastly, what do I do with the negative 3? Add it over. Yeah, exactly. Then you're done. Once again, as I was saying, as you go through these types of problems, the main reason why we always like to put things back into that slope-intercept form is because of the graphing calculator. And for those of you guys, I think there's only like 3 or 4 juniors in this one. Those of you guys that are taking the ACTs later this year, that y equals button is going to be your best friend on that calculator because it's going to help you find and solve problems real fast. But it's a matter of being able to get it into that form. Okay? So I'm going on a limb. This is refresher right now again. Now, let's talk about parallel and perpendicular, see what you remember about that. If 2 lines are parallel, what do they have in common? The slope. If 2 lines are perpendicular, what do they have in common? Or what do they have about their slopes? Opposite reciprocals, yeah. And when we're talking about the reciprocal, what are you doing? You're just flipping the fraction. So if my slope was negative 1/2, what's the opposite reciprocal of negative 1/2? Positive 2. Remember, change of sign is, yeah, change of sign is it's the opposite and you flip it. All right? So what happens in this class then, you guys remember that symbol? / means parallel. So if I want to write the equation of a line that is parallel to y equals negative 3x plus 2, and this one's going to go through the coordinate 3, 2. When I do these parallel and perpendicular problems, I kind of oversimplify it. For any parallel or perpendicular problem, the first thing I always want to do is I always want to identify my original slope. Okay? And I know for you guys this might be a little much, but I like to think in terms of very systematic, very organized way of doing things. Math is so concrete. If you can follow the algorithm through most of the stuff, you'll get the right answers every time. It's just a matter of not trying to skip too many steps at once. So in this example, if I say my first step is to figure out what my original slope is, what's my original slope of that problem? Negative 3. Good. The next step, is it a parallel slope that I'm trying to find or a perpendicular slope I'm trying to find? What am I trying to figure out here? Parallel. All right, so what's the parallel slope to negative 3? Okay. That second step forces you to reread the question if it said parallel or if it said perpendicular. Because a lot of times students, when they see, because they both start with the letter P, you might accidentally do the wrong one. That's the reason why I throw this in here, just so it slows your brain down for a second, just to go back and recheck it. And then lastly, use point slope and solve for y. So now I'm going to go right back into point slope form with my parallel slope, because it's a parallel problem, and with that ordered pair, 3, 2. Y minus 2 is negative 3, is x minus 3. Distribute and solve. You're done. Now, when you guys first did parallel and perpendicular slope stuff, it was probably at like in 8th grade, I'm guessing. I don't know if they were as specific as I am with them. That's just how I've always taught it, whether it was in advanced algebra last year, or geometry we do it, or even when I taught algebra 1, or even pre-algebra. Or every level I do this with, by forcing you guys into just slowing down, it just makes you rethink it. That's all. And I don't want you guys to think that I don't think you can do it right off the top of your head. It just takes one quick second. Now, do I require that you write all that out? No, not at all. But do you see how it can be helpful? Let's see, I think the next one was a perpendicular one for you to try. Oh. Skipped ahead here. Sorry about that. Got out of sequence. There it is. In this example, I would like you to take a minute or two and write the equation of a line that is perpendicular to y equals 2x minus 3, and it goes through the coordinate negative 3, 4. All right, take a few minutes and try that one out. So once again, in this case here, mark over there. It's a good thing to give me more than one. My original slope is 2. This is a perpendicular problem. So the perpendicular slope, if the original slope is 2, is? Negative 1/2. Very good. Thank you for not saying negative 0.5.
Negative 0.5.
There's always one. It's usually mom.
I was thinking about it. I was like, maybe that's the
So then we fill in the blanks. Y minus 4 is negative 1/2 x plus 3. Distribute out and simplify fractions. Now, I will show you a little trick in your calculator because I don't want you guys to use decimals unless the problem starts with decimals. What did I do wrong? Oh, okay. 'Cause I never make mistakes. Do you guys know how to use the how to convert decimals to fractions in this calculator?
No.
I will be more than happy to show you. So, we all agree we have to add 4 over, correct?
Yeah.
All right. Now, in your calculator, if you just type in alpha y equals, that's how you create that fraction bar.
Yeah.
There it goes. Sorry, it's taking forever. Then you can create, just type in negative 3 over 2.
Wait, which one do you choose from?
Yeah.
There's
The first one. Then it should say ND, I believe.
Yeah.
That's just going to be, that's how you create any fraction. It could be an improper fraction or whatever. I try to stay away from all mixed numbers because mixed numbers are a big giant pain. So alpha y equals that first one, and then I'll type in negative 3 down arrow over 2. What was it? What did I have to subtract? I forgot already. Add 4. And it'll spit it out right away for you. So the calculator will spit it out for you right away if you use the alpha button. If you don't use the alpha button, let's say you just typed in negative 1.5. All right? Let's say you typed in negative 1.5. Because sometimes people with the very simple fractions will use that decimal equivalent real quick as you're typing it in, and then add 4 to it. It'll give you a decimal equivalent. On these calculators, if you hit math, enter, enter, it'll spit it back over to the calculator, to the fraction. You probably have the older operating system. All right. Do you have the alpha button? Does it do the fraction? Okay, cool. Does anybody else not have, or on the Inspires, there's a button. I gotta find it. Yes, sir.
Mine, what is the decimal?
After you hit with the first time with the alpha.
Yeah, but negative 3 with the
Okay. Hit math, enter, enter real quick. I know there's a mode on there. I can switch it for you. But if it does that, if you hit math, enter, enter, it should spit it back out.
Okay.
But before you leave, let me see if there's a mode. I think I can switch the mode on there, and it'll kick out a fraction then for you. All right. Hey, look at that! You learned something new on your calculator today.
Yeah.
Yay! It's exciting. Don't worry. It's the first of the month, or the first Tuesday of the month, and it's 10 o'clock. There's no tornadoes. I'm looking outside, and I think we're going to be all right. Here is a new topic. This might be new to you. I don't know if you guys have ever dealt with this in the past. You ever heard of a thing called direct variation?
No.
All right, cool. We're learning something new today. direct variation. Direct variation is basically y equals mx plus b without b. That value of k acts as if it's a slope. There's just no y, the y-intercept is 0. The b value is always 0 here. So it always starts through the origin. Now, the reason why I wanted to reintroduce direct variation with you guys is that later on in second semester or chapter, we do inverse variation and joint variation and things like that. And if you've seen what direct variation means, the rest of it, it's fairly simple. So what happens here is that you're going to hear the following statement. X and y vary directly. And then it'll say y equals 12 when x is 4. What is y when x equals 5? Now, the direct variation problem always has this equation. Y equals k times x. I'm giving you a y and an x. What do you think you have to solve for? Okay. I'm really not this fun. So I'm trying to solve y equals k times x. Well, y is 12. X is 4. What's k equal to in that first part? 3. So what you're doing is you're solving for the k value to reuse here. That k value is allowing you to figure out the generic equation, y equals 3x. There's your slope. Your slope is 3. So now, what is y equal to if x is 5? Well, that's what direct variation is. In pre-algebra, or yeah, I think in pre-algebra or algebra 1, a lot of times they use direct variation to introduce students to slope because they're one and the same. All right. So what you're going to see here are some very simplistic words. X and y vary directly. As soon as you see that, that means y equals k times x. I don't know why they switch it from k instead of an m. I'm not exactly sure on that, but that's how that sets up. And then they're going to give you one values, x and y are equal to this. Figure out what k is. Then reuse that k value to find the next step. Not too terrible. Pretty easy for a Tuesday, I guess. Same idea. X and y vary directly. X equals 2 when y is 7. What does y equal when x is 8? X and y vary directly, same exact setup. If x and y vary directly, that means they have to follow the same exact pattern. Y equals k times x. I know what y equals, and I know what x equals. Y is 7, x is 2. That means k is going to equal, 7 over 2. Should we leave it as 7 over 2? Absolutely. Absolutely. Do you have to put it as 3.5? It's usually, if you think in the back of your mind that it's the same thing as slope, are you ever going to walk a 3.5 slope? Right. But you can walk 7 over 2, right? It's just easier. It's just more of a standard thing. If you do it like that, it's not the end of the world. But I just want you to remember when you start talking about it, like mathematically etiquette, usually the left is a fraction. That's all. And then once again, just use this k value to solve for y. Did you get 28? Look at that. You learned something new today. Not scary? And a handful of homework problems? All right, let's get you a couple problems. Now I've split this up into a couple of different sections, a couple of different parts here. What I'd like you guys to work on for tonight is on page 81. And that's in section 2.2, numbers 55 through 58. And then on page 95, that's section 2.4, 25 through 28, 38 through 40, and 43 through 54. Okay. On the website, remember, it's in the Chapter 2 tab, and it's under Section 2.2, which will spit you off to the very beginning of that section. All you have to do is just scroll through it, and you will find the page number. It's in the lower corner. Same thing with the page 95. It's in Section 2.4. Click on that link. It'll pop up for you. If you don't want to use the websites right now, because obviously it's fairly simple, there's just a couple of problems, take your phone out right now, take a picture of the book if you've got the book with you, and there's your homework problems. Not a big deal. Okay? Make sense? We'll go through those tomorrow. We'll get into more of the word problems. Start building vocab from word problems. Exciting.